Good morning, everyone.
Good morning.
Welcome to the Science Museum of Virginia. As you heard in that long list of accolades that Brian dug up from my LinkedIn, I am Dr. Jeremy Hoffman. I'm the David and Jane Cohn scientist here at the Science Museum of Virginia. And I've been tasked with kind of opening the ceremony today in many ways, trying to connect the business side of things to the climate side of things. So I'm going to start by going through a short story about myself and why I show up to the climate work that I do in my job, then go through a little bit of the trajectory of climate change opinions in Virginia, and then focus on what we know, and how we know what we know about climate change, and landing on how do those impacts of a changing climate really affect some of the sectors that you're going to hear represented on the illustrious panel that will follow me. So, in order to get started, and as Rich, I think my boss, Rich Conti, would know, I like to embarrass myself at the start of every one of my talks. Now, beyond the fashion sense that you see becoming popular again in Generation Z, on the far left, the flood shorts were really an early adaptation of mine. The important picture, or the important thing about these pictures is that I spent most of my life enjoying the outdoors with my dad, going fishing in northwestern Wisconsin. And some of my most core memories of those trips to northwestern Wisconsin focus on the walleye, which is a bottom-dwelling, cold water-dwelling fish that is really celebrated for its taste. My dad used to make fried fish and eggs with walleye on Saturday mornings when we were on vacation, and I swear, it doesn't sound very good, but if you're from the Midwest, it is a culinary masterpiece. And when I was in graduate school, friends started sending me newspaper clippings that were really a confirmation of something that me and my dad had actually experienced throughout the time that we had been spending in that region of the United States, namely that there was a major walleye decline happening. So there was fewer and fewer walleye being caught by the local anglers. And you can see just how important that was to them because it was a big issue. Well, one, they have a really important ecotourism industry in this part of the country. People flock to the north woods of Wisconsin during the summer to go fishing. Now, you can also see its importance in the Sawyer County Record. The logo itself has a fish in it. So you can see just how important that is to their local identity and ecotourism industry. They were scrambling to find out a reason why there would be this long-term walleye decline. Is it species interactions? Is it overfishing? Is it food? Is it temperatures? It's a mystery. Well, luckily for us, science can help us observe those systems methodically over time to arrive at a conclusion. And the USGS and the local DNR, the Wisconsin DNR, found that the only consistent change across all of these different lake systems in the state of Wisconsin was that the long-term temperature had gone up in those lakes. Now, if walleye really like cold temperatures, this meant that they weren't being as successful in reproducing every single year, leading to a long-term decline in the young versions of those walleye that then turn into the big ones that you can catch and eat. Now, why were the lakes warming up? Well, this has been consistently, repeatedly concluded in a bunch of different studies that climate change is to blame for this long-term warming of the lake system. So this is a global issue having a localized impact on an ecosystem that then cascades through an ecotourism industry in Wisconsin. Now, this is now on the Wisconsin state government website as one of the main concerns about climate change in this part of the country. This means, preparing our communities for changing the type of fish that they try and do on fish fries on Friday nights, which I'll tell you, largemouth bass are nowhere near as delicious as walleye. So when I talk about climate change in this respect, it's really about, and my experience with it is around this kind of intergenerational experience, sharing the kinds of traditions and values that we have in our communities across generations. And climate change threatens that, not only in Wisconsin, but here too. Long-term records of temperatures and streams across Virginia have shown that almost without exception, long-term warming of the climate system has had a direct impact as well on streams here in Virginia. Now, many of you who might be fishermen yourself, or fisher people yourselves, might be familiar with another delicious fish that really likes cold water, the brook trout. And so other communities here in Virginia may be having those same sorts of traditions and values threatened by climate change locally here that may affect their ecotourism expectations and planning for the future as well. So I start my conversations like this because I like to think of climate change as this intergenerational issue where thinking ahead to the future and what we want to share with the generation that comes after us and the kinds of things that we like to do now, are we going to be able to share it in the same way depending on the outcomes of the next few decades? So speaking to the next few decades, I want to reflect on basically the last decade of work that we've done here at the Science Museum and the shifting of the Virginian kind of adult population's opinions about climate change. In fact, there's been some surveys that have gone around for years now, since 2008, and so we can compare over time, how do Virginian adults kind of perceive their relationship to climate change. So I'm going to show you a series of maps, and if they're purple, that means fewer people agree with a particular statement. If they're green, that means more people than back in 2008 agree with that statement relative to climate change. And so the big ones here are that, and I'll draw your attention to some of them that I feel are the most important, at least from the Science Museum's mission, is that there's a major growth in the number of adults, or percentage of adults that agree that there's a scientific consensus. There is an agreement among scientists that climate change is happening. Now, another one that's important is that climate change is already harming the United States in some way or another. There's been a huge increase in the number of adults that agree with that statement. And then probably most importantly, with respect to the story I just told you about myself, is that many more, almost without exception, adults across the United States agree with the idea that climate change will harm them personally in some way or another. And in this case, harming my ability to share walleye with eggs with my niece. Now, another question that they ask is, who should be doing something about climate change? And here in Virginia, interestingly, adults agree that everyone should be doing more. From government to local, all types of levels of government. But really interesting for this conversation is that more adults think that corporations should be doing more about climate change than any other form of government in the state of Virginia. Almost 3 in 4 adults agree with that statement. So let's let that kind of context that has shifted appreciably over the last few years, kind of thinking about what's going to come next. In as much as I'm going to now go through kind of, well, how do we know what we know about climate change? Just to try and to talk a little bit about the amazing work that has gone on in climate science over the years, and then we'll start talking about the impacts of climate change, okay? So, in order to do that, we have to do a history lesson, but I swear it's not a boring one, okay? The history of science is actually really compelling. Now, the first one we have to meet is Joseph Baptiste Fourier. He is a famous French mathematician known for his work in statistics, but he had also done some really important early work on a thing called the greenhouse effect. So in 1824, the same year that Braille was developed, Joseph Baptiste Fourier determined mathematically that the greenhouse effect exists on the planet, leaving Earth relatively warmer than it would be otherwise. Now, he didn't use the term greenhouse effect, but later scientists would determine that name accordingly. Now, fast forward about 35 years, and we have John Tyndall. He's the first scientist that's credited with taking all the different gases that are in the air that we breathe. You know, we take air for granted because you just breathe it all the time, but it's actually comprised of a bunch of different other types of molecules. And those individual gases that make up air are super important to the warmth of our atmosphere, one of them being carbon dioxide. So what Tyndall did was to actually isolate those gases and then experiment with their ability to absorb and then re-radiate heat. Carbon dioxide tended to be one of the more powerful greenhouse gases that Fourier worked out mathematically. So you can already see a bit of an advancement in the way that science was being used and built upon. Fast forward another 30 years, lose the mutton chops, add the mustache. We've got Svante Arrhenius, who in 1896, the same year that the stop sign was invented, determined mathematically by hand how much the Earth's temperature would change if humans doubled the amount of CO2 in the atmosphere. His reasoning was because the Industrial Revolution was at a fever pitch in the late 1800s, and he was seeing so much industrialization and utilization of different types of fossil fuels, and all this burning of this stuff was creating this smoke, and a big portion of that was carbon dioxide. So he asked the question, how much would global climate change if we doubled the amount of CO2 in the atmosphere? Because it keeps us warmer than we would be otherwise, and we know that CO2 is one of the most important greenhouse gases. Now we know his answer was a little bit on the high side, but given that he did it by hand in 1896, I think we'll give him a slight bit of a pass. It turns out since then, we've just been refining the details, but one last little person I want to introduce you to is Guy Stewart Callender, who in 1938, the same year that the War of the Worlds first appeared on the radio, made the claim that the global temperature had already gone up in relation to human emissions of heat-trapping gases like carbon dioxide. So in 1938, the answer was basically already in front of us. And now in the decades since, we've become more sophisticated with our ability to represent the climate system in computers, and then delve into more of the very, very fine-scale aspects of what global climate change really means. But I just wanted to go through the history of it because it's so compelling that since the 1930s, we've basically had this science relatively conclusive. Now, the overarching thing here is that CO2 basically creates more blankets for the atmosphere. It's the same reason why you get uncomfortable having too many blankets at night and you throw one off. Same too is going on in the atmosphere in a very basic sense. Now the physics are a little bit more complicated than that, but that's the general outcome of over almost 200 years worth of science, is that adding more CO2 is like adding more blankets to the planet. Now, how would we even know about it's carbon in the atmosphere? So for that, we have to go see this guy who seems to be holding a volleyball up to the sun in Scripps in La Jolla Pier in California. But really what this scientist is doing, he's a famous scientist of the Keeling family, is actually taking a little flask of air and filling it off of the wind that's coming off of the Pacific Ocean. What he does is take that flask back into the lab and makes a determination of the concentration of CO2 in that air. So his dad started that before him, and in the 1950s got the first global observations of CO2 in the atmosphere going. And so this chart up on this graph is going to be more CO2 as registered by those flasks, and to the right is going to be closer to the present day. Okay, so the 50s are on the left, and the present is on the right. One of the most famous charts in geophysical history is the Keeling curve, showing that CO2 in the atmosphere has been going up over time. We have now been able to take the actual carbon molecules that are in the air and look at the flavor of carbon that's in them. You know about isotopes? Well, isotopes are basically flavors of those different elements. And conclusively, now we know that the flavor of carbon is clearly linked to mostly fossil fuel emissions. So this is from burning fossil fuels, basically increasing that CO2 in the atmosphere. Now you might be recognizing too, there's this really interesting seesaw or like sawtooth pattern. That turns out to be the Earth's breathing in and out as the spring photosynthesis absorbs CO2, and then into the fall as those plants die off and then re-release that CO2 back into the air. So that little sawtooth pattern is the natural world breathing in and out seasonally, which is just such a cool representation of the carbon cycle. Now, in order to go even further back in time, we have to rely on paleoclimatologists, like yours truly, who go out and find natural archives of Earth's history to then investigate how weird the present day is. Because saying 420 parts per million, that's only 0.04% of the atmosphere, Dr. Hoffman. Why would we be worried about that? Well, in order to find that out, we have to go to a place like Antarctica, dig deep down into the ice where it has layered itself off from snow that falls every season. And interestingly, as it gets compressed down, it locks into ice and captures these little tiny bubbles that happen to be full of atmosphere. Much like those flasks that scientist was filling from the Pacific, we have little tiny flasks of air trapped in ice in Antarctica. So, one of the most amazing findings from this work in ice cores in Antarctica was that they overlap really well with our direct observations. So on this chart, again, CO2 up, more CO2 in the atmosphere, more recent to the right, okay? And the blue dots here represent the CO2 that was locked in those individual little bubbles in those in the little layer cake of ice. And the blue. So that's since the 1830s or so, and then, it overlaps with the 1950s. If we overlay the CO2 from direct measurements done by the Keeling family, we see the close correspondence being one of the best discoveries, because that means we can use ice to investigate pre-human trends in CO2. That's a hugely important observation to make about why is climate change, and how weird is climate change in the present day. So I put up here a star of where we're at. So this is about 420 parts per million in the present day. This graph is also up, means more CO2, but to the left, that's 800,000 years ago. Turns out we can actually date those layers of ice back to almost 1 million years. And when we analyze those little tiny bubbles for their CO2 content, we see a breathing in and out of the global climate system in step with the ice ages of the last 1 million years. So anytime that CO2 is relatively low in the atmosphere, the Earth was very cold. Anytime it was relatively high, the Earth was relatively warm. Now, what is the other dramatic finding from this work is that any time in the last 1 million years, the Earth hasn't been able to release as much CO2 as humans have. So it's the rate of change that is really incredible when you compare the natural cycles of climate change to the present day one, which is because of this release of CO2 into the atmosphere. To give you some context, humans, depending on the estimate, evolved about 300,000 years ago. And so even our own species haven't lived on a planet with this high of CO2. Now, you might ask, well, what about in previous times? It seems like other lines of evidence support the idea that there's never been this much CO2 in the atmosphere for at least the last 3 to 5 million years. So it's really a special atmosphere that we are living in today versus the recent Earth history. Now, of course, this has led to the conclusion that that release of CO2 has directly warmed the Earth's atmosphere. And so this is a really dramatic representation of that, known as the warming stripes, where each one of those bars represents an average annual temperature, and the color corresponds to how weird it was relative to the 20th century average. Well, in this case, this is the 1971 average to 2000. And so you can see a lot more in the relatively present to the right are very red. That means that they are exceptionally warm relative to the last 150 or so years. It turns out that the amount of warming we've seen, about 1 degree Celsius, is more than has happened in the last 10,000 years at least. So what does this mean? What does this mean about our potential futures? Now, if we know that human emissions of heat-trapping gases are driving this warming, then we can lead us to investigating what that might mean into the future. So what climate scientists do is to project potential future outcomes related to how much carbon we put into the atmosphere long term. That's the question, is what are humans going to do? That's the biggest source of uncertainty about future impacts of climate change, actually. So what we have here is, that's the warming that you just saw represented as colored bars. We're there, about 1 degree Celsius warmer than the pre-industrial. And what climate scientists do is to create a variety of different scenarios of the future. One of them being where we don't do any sort of cuts to those emissions of heat-trapping gases. We just keep putting that into the atmosphere over time. That leads to a warming of about 4 degrees or 5 degrees Celsius globally. That's about 10 degrees Fahrenheit. Now, on the opposite side, there is a future where there has been very substantial cuts in emissions. This is very close to what you might hear as net zero futures, where there are net zero carbon emissions from our industries and things like that. And that leads us to under 2 degrees Celsius of warming. So you might be wondering, well, where are we? What's the trajectory that we're on right now? Those two sound like, one sounds pretty bad, the other one doesn't sound as bad. Current policies put us somewhere close to 3 degrees Celsius. So we're not on the worst case scenario anymore. as far as we can tell, our current policies do not put us on those very high levels of warming that you might have heard of in recent decades. But we are substantially short of what is the goal of the Paris Climate Agreement, which is to limit global warming to under 2 degrees Celsius. So it's really helpful